Okay, thank you again for everybody coming. My name is Joseph Clevenger. I'm the lab manager for what we call our CompoZed lab. It's an innovation lab. Background, I actually have 27 years of development experience, so I've been doing Java, or had been doing Java since about 2005. So I've got quite a bit of Java experience myself. But I'd like to introduce my panel, additional panel members. So I apologize, we're not going to, if you expected a presentation, we don't really have anything to present. We thought that maybe an open panel discussion, and if you would, maybe wait till the end if you have questions. We'll see this is kind of our first time doing this together. I'm no stranger to these two gentlemen next to me. The gentleman on my right is Mr. David Krug, and forgive me because I'm actually now at that age where I cannot read with my glasses. He is the director of systems engineering, which is part of our architecture, innovation, and CompoZed group. So Dave leads the system engineering organization. It's focused on developer innovation, cloud-native application design, and supporting your product teams as they create amazing digital experiences for their customers. Dave's been at AllState for a little over 18 years, building mission-critical web applications since browsers first added JavaScript, and has been thinking in code since programs were stored on cassette tapes. I also have been in that same area.
Like last year, right?
Yes, it seems like it. He's passionate about Agile and product mindset transformation, IT strategy, compiler and framework design, expert systems, APIs, cybersecurity, and building robots with his kids. First, I had to, I thought you taking your kids to the wooden robot, but okay. Okay, so.
That too.
After building robots with your kids, I'm sure you want to go to the wooden robot. So the gentleman on my left is Mr. Dewey Whitler. He is the senior managing engineer for the systems engineering group, again, which is our architecture, innovation, and CompoZed. Dewey leads engineering within the systems engineering organization, focusing on developer experience. Dewey's been with AllState for over 20 years, so he's our most senior member here on the panel. Building mission-critical applications in a variety of business units. Recently, he's focused on building cloud-based applications with lean product mindset. In his spare time, he plays Minecraft and Super Smash Brothers with his son. I could make a joke about that.
It's a solid way to spend the Saturday afternoon.
Yeah, exactly. It's a great way. So the topic that we had came up with, we thought would be very interesting, would be how we think about optimizations for our most critical apps. And AllState has many critical apps, but I just want to kind of help set the stage here. And so if you could first kind of give us a high-level description of what we consider our most critical apps, so we know what we're talking about.
Yeah, so our most critical apps, it's probably going to be impact to the business or just the sheer scale that some of these things run at. So if you think like our customer website, millions of users, always available. Same thing for the systems that support our agencies, not quite millions, but tens of thousands of users that, 24/7 utilize these tools to do the job, run the business, complete all the sales and service. And other applications like in our Arity space or our telematics and data company, they're processing immense amounts of data at scales, moving from billions of transactions a year into trillions of transactions a year. And so pretty much everything in between, right? You've got those very, very business critical systems, the insane throughput systems, all the way down to like our internal employee recognition site, which is really critical for employees, but maybe the business impact is a little bit lower on that one. So full range of small scale apps, dozens of users, all the way up to millions of users, millions, billions of transactions type stuff.
Okay, so that's kind of high level, but we're here to talk about some optimizations. And so can you tell me what is the impetus, or how is the decision made that an optimization is absolutely necessary for one of our critical apps?
Yeah, maybe that's when we even open up to the group. I mean, I think a lot of teams are really quick to kind of jump into, we've got to take performance tuning to the nth degree. In fact, you may even run into some problems by doing that. So some of it is, figuring out initially just what the baseline of the system is and figuring out the norms. Sometimes it's just noise, right? Users are complaining. Hopefully it doesn't get to that point, but it has, right? So I think you're always looking for that signal in the noise that it's time to maybe do something about it, because it can be difficult to track down some of these problems. You can invest a lot into various different performance tunes and optimizations, and a lot of times maybe you don't get the payback on that you were looking for. And sometimes even maybe the architecture, you've just outgrown it and you need to start thinking beyond what you could do with a couple of JVM tunes or something. But it's really...
Well, you mentioned a baseline. How do you know what your baseline is? Like how do teams, how do they get that?
You got to measure it, right? So I mean that's one of the mistakes that we've seen some of the product teams over the years kind of make, is you get the product to a point where you start to experience some things that you're not happy with, right? Whether it's throughput or even on the availability side, but you don't have the proper measurements in place to be able to even start to figure out what's going on. I mean, you could go line by line of the source code, but that's probably not an efficient way to do it. So, having the right tools in place, the right level of logging, instrumentation, can be a big investment to instrument applications by hand well. We've done it successfully over the years. It takes a lot of time, can take a lot of skill. If you can make the investment, or you're fortunate enough to have license for APM type tools, and you can kind of get that level of instrumentation for free, that's a good way to start. But you need some baseline to understand where you are, where you're trending, how it's changed over time. Did you lose X amount of performance literally with the last change set? Or is this something that's just been building up, or it's just the right set of conditions, all the stars align and something janks, and then what do you do? So I think having those tools in place and understanding what the performance characteristics are of the system are just really, really important.
So what do you think about, in the past, I know we've created our own instrumentation versus, you mentioned purchasing a product. So what are maybe some experiences you've had, pros and cons of doing one versus the other?
Well, I mean, if you're going to do it, if you're going to roll your own, make sure that you're not introducing more performance bottlenecks by that. But I think it's having a plan. So having good correlation in distributed systems is important. Having good duration instruments across. I really know that it's not necessarily occurring in my code that this latency or lag is happening. It's when I'm making this outbound call, and then what is the outbound call? Something simple like database call? Is it something like another service call? Where, just getting the timing and sequencing. So if you're going to roll your own, there's a lot of good open source frameworks for distributed tracing and instrumentation. If you're going to start from scratch, think through what are the most important things that you're going to need to measure. And then once you collect all that data, what are you going to do with it? How are you going to visualize it? How are you going to make sense of it? Probably going to pay to store it and all that fun stuff. So if you're fortunate enough to be able to go acquire maybe an APM product for the app, and if the system is critical enough, maybe it warrants the investment, right? And then you can just get a lot of this stuff for free. Now, we've certainly run into the situation where the APM product itself is causing performance issues, and that's always a fun one to work through with the vendor. But at least that way, you're probably getting a good level of coverage.
Okay, so
I was going to add too, I think you got to plan for it up front. A lot of times with these performance issues, you don't want to wait until they happen. So you want to have that metrics or the needles to move up front. A lot of times when I've seen products and applications rolling their own, it's usually an afterthought. So if you're going to do that, just plan for it, make sure you get in the product as part of the product that you're delivering out to the consumers so you can collect those metrics early on.
Isn't that like the worst experience? So you get a call from a customer, they're like, your system was slow or something didn't work or it kind of janked, and you go, yeah, what time did that occur? Like, it seems like you should know, right?
So that's even another question, is it's not even like what you should be doing or how you should be measuring, but it's like when in the process you should be doing it.
It's one of those things early on.
It's like security,
yeah.
right?
Yeah, anytime you got to bolt something on after the fact, and whether it's the instrumentation, like application telemetry, or heaven forbid security, like it's never...
Just retrofitting.
Yeah, it's not what you want, probably. So make it part of the core design. And I think as we kind of pivot into more very product-centric ways of operating, and some of the lean enterprise that you talked about during the introduction, we get into this mode of like, what's it? It's okay, it's MVP. MVP doesn't necessarily mean like your product's running blind in production. In fact, how could you even kind of test and learn and iterate if you don't have some basic metrics? So we've seen both here, right? We've created products where the instrumentation and app telemetry is like absolutely critical. We will not go out with an MVP without it. We've also seen other products that have taken a very minimalist approach to their first deploy, and then they're running blind. And you probably don't want to be in that situation either.
And maybe I should take a note. So we don't add it like a week before we go to production, right?
Maybe that wouldn't be the best.
Okay, all right. Okay, so again, we're talking about optimization. So let's talk maybe a little bit about some optimization techniques. And again, this may be like a really general question, but like what are some of the first things that you look for as far as optimizations?
Right, we've seen so many things over the years, and unfortunately, so I had the opportunity years ago to read a lot of the Windows-based memory dumps for the company. If you ever get an opportunity to do that, so I'm like one of those rare people that love blue screens of death. Like, there's always something cool to find out that's happening behind those, and it's always in the dumps if you can find it. You wouldn't believe the number of times that people would do silly things, like leave sleep statements in their code. We've seen it. Or get really, really creative, and I've come up with this new locking construct. Maybe not a good idea, and so some are just self-inflicted.
Well, how about some of the like low-hanging fruit?
Exponential time.
It's like
loops.
you could have the argument over like, concatenating strings. So I use string builder,
The
string buffer.
Old string builder.
Yeah. Does the compiler do this for me? Like.
Now.
Yeah.
Like back in the day, right? It didn't. So that was always a big thing, It's actually part of the interview questions that we used to have with developers. Like, do you understand what an immutable type is and why that's important? The compilers, of course, are getting smarter now that they're doing optimizations and replacements. Like, they'll probably put a string builder in for you on your behalf. They may not always do the most optimal job of doing that. So I know Java will swap that out for you, but in the context of loops and other things, it may be creating more like string builder objects than you really need. So that's something to look for too, But again, you gotta have the measurements in place. Okay? You can go tune every little line of code that you have in the application. I don't know if that's the best use of your time. You gotta find the hot spots in it, and so the instrumentation will help you at least start to narrow down where to look. But yeah, look for inefficient algorithms, especially exponential time loops. We still see those.
Infinite loops.
Not quite infinite.
Not so much. There's almost never an infinite loop because the system will crash before it gets close up to that level. But
And we're usually iterating through collections and things, so it's a lot more
I think
difficult to
so.
do
I
that
mean,
than
think about the
writing
code we all
for
write.
loops. Yeah.
There's always that stuff, and we do a lot of in-memory processing, as I'm sure a lot of folks do, and so you got a lot of complex loops and logic, and even choosing maybe the right data types for the job. And I mean, these are very basic constructs, right? Like if you're going to consistently need to loop through even smaller collections of data, does it make more sense to build up just a quick index of a hash map or something, so that you're not just performing that grind over and over and over? Now again, if you're working with really small collections and really small data sets, a lot of this doesn't matter. I mean, the hardware is so good these days, even what was a problem that we'd probably tune out about 10 years ago, you could probably get away with it. And it kind of goes back to the original thing about finding and identifying or establishing the SLAs, like when is it painful? But have the tools in place so you don't have to wait for somebody to call on the phone and go, hey man, your system is really slow or it sucks, it doesn't work. And you don't want to get to that point either.
Okay, well, you mentioned memory dumps, so that's a more advanced technique for analyzing applications. So like, what would be some more techniques, or what would you do for more advanced tuning of your applications?
You want to start this one?
You can take it out, chime in.
So I don't know that there's a secret formula for this. I mean, if you're having to do the post-mortem analysis on memory dumps, you probably screwed up along the way somewhere, right? You're lacking in instrumentation, you're blind to something, you can't figure it out. You're going to go walk and analyze the heap and see if there are other things that are maybe leaking or going on. I mean, that kind of leads itself to, at some point, you start getting into the inevitable business when tuning for throughput on JVMs and GC tunes and all of that fun stuff. But looking
How many
at
settings are there? Like,
have you guys issued like a print, like all print flags final, I think is the flag.
Yeah, that's what it is.
Is that the switch?
Yep.
Have you ever run that command? There's hundreds of these things. In fact, I think if you turn on some of the experimental features of the JVM, and then there's also, I don't even remember what they're called, some of the more advanced debugging features of it.
Some of the diagnostics tools. I'm sure.
Literally like over 700 tunes that you can make. I don't know if anybody knows what all of those 700 actually do, but
There's a quiz afterwards.
I'm not going to do very well. I can probably pick out a handful of them. But you start getting into that. I mean, from a more advanced perspective, right, our applications that we tune to maximize for throughput, understand like Java is trying to do its best to figure out what you're trying to do and set itself up accordingly. Now there are times when that doesn't really match. So if you're trying to tune a workload for mass amounts of throughput, then maybe you need to start taking a look at like which collector you're using for garbage collection. By default, if your system is detected as a server or you force the flag on it, you're probably going to run the parallel GC out of the box, which is better than the serial GC, right? So maybe just a brief overview on garbage collection, right? You got managed heaps. Like it's not like unmanaged heaps where you're going to manage all the memory allocation and deallocation yourself. Garbage collector is going to try and help you out as best as you can with that. And those usually happen like when you use up enough memory, or the heuristics say it's time to start reclaiming some of that space. You know, it goes through a couple of phases, right? It's got to go through, walk all the thread stacks and find out what's alive. So we call that marking. And then it's going to ultimately, it may take a couple passes at that or do a couple things there. And then it's going to do a sweep where it's going to try and deallocate, you know, the dead or orphaned objects. And then finally it'll do some sort of a compression, a compact. It's going to move all that, you know, Swiss cheese space all together, so you got a nice big block to allocate against.
So I think the point is like doing like even these GC tuning, your mind could be Swiss cheese. Like
yeah, if you
just
stare at the settings enough,
yeah.
like, because by default, again, if you're going to run on the parallel GC, it means it's still going to block. So when that garbage collection occurs, your application processing is going to get halted while it does it. And at least it's not going to do it just serially, right? It's going to attempt to parallelize as it goes through those different phases, but it's still blocking. So if you need to tune an application for really, really high throughput, you're probably going to want to look at one of the other collectors that are available. There are several, as of like JDK8, and they continue to add to these. I mean, we tune some of our highest throughput apps with the CMS collector. So there's concurrency, you know, that's going on with that, and even that's not 100% non-blocking. It's less blocking. There's two like stop the world blocks that occur with the CMS collector, and it's all during the marking phase. It's the initial marking when it's going through and it's trying to find which objects are alive, which objects are dead, and then again when it does what's called remark, because it locks all the app threads, it does that initial catalog of the thread stacks, it then lets loose kind of a concurrent, and it's called concurrent because it's able to run while the application is running, all the other objects that are in like the young and older generations. And then when it's done with that, it's got to pause everything again and do a remark because maybe the state of that has changed during the really quick, you know, while it allowed the application to run again, and then finally cleans that up. And so that we found, and again, this is before G1GC was available or ZGC was available, really started to add a little bit better and predictable throughput into like some of our web-based server loads. Because prior to that, the way it would present, you'd have an API to be called, you know, really, really high request per second counts. And it would be fine in lower environments. It would be fine under even normal load. And then you would just get these weird like janks and spikes in the response times. And it just all happened to do with when, you know, GC is firing up and whether it got tricked into a full GC and how much time would that take. And we run some big applications as well. So it takes a little longer for the garbage collection to happen. So in some of our apps, we were finding like APIs would just sit there and freeze for like 5 seconds in some extreme cases. And you know, we were lucky, we've got APM tools and other things in place where you can just go to a dashboard and see, oh yeah, this is why it got locked up in GC for that amount of time. And it makes tuning a lot easier. Now, if you didn't have that, then you're relying on other kind of out-of-the-box metrics to help you find it. But it comes down to, you know, the level of sophistication of the app, how much throughput, like do you make investments in those tools, and then they can kind of help you track it down.
Well, there's, I know this is probably strike a chord with probably maybe a lot of people in here. You're a Spring engineer, okay? So we use Spring in the lab. I use Spring before Spring Boot. So sorry. I had mixed feelings about it being so opinionated. So when we're talking about tuning, like Spring is like that's even like a whole nother level, right? So it does a lot of things behind the scenes, makes a lot of assumptions. So like what kind of things have we seen and what kind of optimizations like have we had to do just with the framework?
Yeah, I think a lot of it from Spring, there's a level of abstraction that keeps getting overlaid on top of each other. So you have Java, then Spring Boot, which makes things really easy. You can get things stood up, you can get them deployed like instantly. But when problems start occurring, a similar type of experience is trying to identify where those problems are at. So like one of the examples that really comes to mind a lot of times is when we start doing database, we're using JPA. It is really good for rapid development, getting things out quickly. But if you're not familiar with like the underlying how it does fetches, a lot of times, a lot of pain points are we're just not configuring JPA or utilizing it correctly. So again, it's identifying that we're having a problem with some sort of SQL statement. A lot of times, maybe it's just some configuration changes for JPA to do eager fetches and other things. A lot of times, maybe it's I need to rewrite my SQL, use indexes appropriately in a database. But it's really trying to identify those. So whether it's using the our own SQL with the template, or even maybe transitioning to if I have a lot of records, maybe I need to write a stored procedure and leverage the database to crunch that data and just return what I need back. So it's really trying to understand where that problem is.
So also with Spring, there's a little bit of latency on startup. I do recall some issues maybe with.
Yeah. So I mean, other examples and things that we've seen just from performance in Spring, as we deploy in our cloud-based environment, things need to start very quickly. And leveraging a component scan, the more things that you add, a lot of times, like the more you add, like it works fine locally, but when you get in a cloud-based environment, that startup time takes too long. Your application will crash and retry, and eventually your app won't deploy. We've seen things of that nature as well. I think that really the nature is really still identifying and having those metrics of where the problems lie within in the code base itself.
And speaking of Spring, since we're on that subject, what about we, like a lot of other companies, have a very rich ecosystem of APIs. So what about like our experiences using like Hystrix and timeouts?
Yeah.
What are some lessons maybe we've learned about maybe some optimizations or?
I don't know. You guys got work
design.
tomorrow. I don't know if we have enough time. Yeah, those are in there too. I mean, Hystrix is an interesting thing. Like when the word circuit breakers came out, it was like we reinvented like isolation and retry strategies and stuff all over again. And it was an interesting thing. Like this isn't really on the performance tuning front as much as it is. Like we started to have like architectural mandates that say we should put a circuit breaker around like every integration and stuff. It's like, well, that's cool. What's like the fallback for it? It's like, oh, we'll retry it. Okay. Because that's like another aspect to this. Like a lot of those capabilities came in and made it really easy to do like exponential back-off retries and those types of various strategies to try and bring a little bit more resilience into the applications. But you need to understand what you're doing. I can't tell you how many times you've had systems that start to brown out. They're on the cusp of maybe if someone would just leave them alone, they'd recover. But we use like retry strategies, so let's hammer the crap out of that thing at machine speed, asking the same question but expecting a different result. I think somebody defined that as insanity. But we do that kind of stuff, and then we don't understand what the impacts of that is. So you have a system that's maybe starting to brown out, or it's like in a yellow state if we think of green, yellow, red, and it may have been able to recover, but no, we just slam it because of some slight service variation, and then we end up just taking it down. So that's another aspect, and God, man, you want to talk through timeout strategies, that's another conversation.
Yeah, so I guess what I was trying to, when I was remembering like a couple of those things that, your optimizations aren't necessarily like code-based, sometimes it's architectural, design.
I think, one of the key takeaways, again, if some themes are starting to develop is you got to have some insight into what's going on. You got to be able to prioritize. And then, you know, some of those things, making sure you're making the right investments at the right time. So you really don't want to get to the point where the system's just falling over on itself. It's probably too late, and you're going to try and do a bunch of things that, you know, you don't know if it's going to work. You hope that it works, and there's no silver bullet in this. Like, if there's one takeaway in performance tuning after all these years, like, I could give you our settings for tuning JVMs, absolutely no guarantee that they're going to be any better than what Java and Spring would do right out of the box. Because it becomes so dependent on the profile of the workload, and it changes over time. So we fall into the trap sometimes of, oh, we've got this set of magic, you know, settings, let's throw it at everything. And we've been throwing at it for 2 or 3 years. You know, there's still plenty of apps that use CMS collector. There's better ones out there now. But we still throw the same tunes. So that's the other thing, right? Like, some of these things occur at a point in time. If you're going to make these investments and you're going to make bespoke configurations, you've just now signed up for a lifelong, you got to revisit those on a fairly regular basis. And that goes back to you just always profiling, always making sure that, you know, it's not a, you know, performance degradation isn't due solely to some new code that went into the system versus, oh, we upgraded the version of the JRE and now that's, you know, has a different default in one of those 726 or however many flags that are in there.
You know, one of the things I was going to say too is sometimes you don't have to solve it through JVM tweaks or even changes. Like, if it's slight performance and you're under the gun, scale out. Add a couple more application instances to buy you time. And maybe that's all you need.
I was going to say, I mean, you can spend hundreds of hours like trying to go squeak an extra millisecond out of a call, or maybe you could just throw another server at it, like another instance, to scale it out.
Okay, well, Dewey mentioned something that was kind of like near and dear to my heart. It's both, you know, where I think there's always a lot of opportunity, and also makes me very angry sometimes when I see it. Sometimes I feel JPA is a 4-letter word, or ORMs. Some of my experience, especially like in the early days when I was using like Java server faces and using Hibernate, people don't understand maybe a lot of times the difference between like eager fetching, when things are like, there's a lot of configuration involved in that. So the pros and cons to using something like JPA, it's like, oh great, like you can quickly get up and running with something, but as you scale, you know, like what are some of the things, like my experiences are, it's great for prototyping, but you know, as you scale, you should probably be looking at like JDBC template, you're optimizing. So maybe first we should talk about maybe some of like our lessons learned with like JPA and ORMs in general.
Yeah, I touched on it a little bit. Just it's really understanding of what's being created for you. So this layer of abstraction, like, it's, to your point, is great for prototypes. You can get things done quickly, you can get out to market, learn, it's all good. As our systems become more and more complex, maybe hundreds or thousands of tables, and bringing this all together, when you start using ORM tools, it's very critical that you understand what's going on. So again, having that measurement, but then when you start tracking, like, make sure you understand the SQL that's being produced for you. So a lot of times, like, you know, questions come up.
And you can turn debug on, right? So you can,
yeah, absolutely.
It looks horrific, but
yeah,
yes.
It's really tackling from 2 angles. So if you're lucky enough to have DBAs working at your corporation, also engage them to make sure that you're looking at execution plans on the database side. But it's also understanding from the Spring and JPA, understand what's being produced locally, and a combination of that stuff. Sometimes, you know, moderate-sized application, you can make some tweaks in JPA and probably be perfectly fine. Change how the data's fetched and you'll be good. I've seen examples where applications have like some had concatenation in their app and returning very large record sets. And it's not uncommon to retrieve 1,000 records, but the way that's chunked up and retrieved from the database, it'll chunk it up in sets of 50. I forget what the exact number is. But then you have the latency of going through the network calls, and just the number of times that you're going back to the network to fetch that data slows your application down.
Yeah, you need to know what it's doing to get the optimization.
Yeah, so a lot of times it's just tweaks.
And it's tweakable.
Yeah, it is tweakable, and you can make those slight changes and very quickly get from a very slow application to something that's reasonable. But I will say, just lessons learned over the year, whether it's Java or any other language, sometimes you just need to write to SQL, leverage the index.
Do we? I think you still, like, I sit very close to Doug. I think he looked at my cards on my desk, honestly. Because that's the point I wanted to get to. That's like the next thing I really wanted to talk about is like these database optimizations. So there's so much you can do, maybe in JPA, and you mentioned maybe you're lucky enough to have a DBA or not. So like what kind of optimizations, like, okay, now here we are, say you're writing your, what kind of other things can we do that are like maybe a little bit more advanced, like in general, database optimizations, like what kind of things do we look for?
Well, one thing that comes to mind for me, right, if you have a large data set, and sometimes you'll retrieve that entire data set, you'll do the processing within your Java app, and maybe to produce a number or a subset of rows. But did you really need to return all the data from the database back to Java to do that processing? So a lot of times, again, if you can rethink and maybe leverage the database through stored procedures, is an example of that.
I think we tend to see teams that want to stick with a single pattern. So I want to go all in on JPA, or I don't want to maybe write SQL for one call, or if you have to go into Sprox, because they want to stay consistent. I don't know if that's a really good rule to follow. You got to use kind of the right tool for the job. But just more maybe in general, there's so many things that you can tune. We've seen product teams that have attempted to just put what they believe to be like a timeout on REST template. And they think it kind of works like some of the higher order frameworks for invoking services where this timeout represents the total duration of the call. And the reality is that doesn't really exist in Java. There's a socket timeout, but that's not really the same thing, and we see people using it that way. But that's just going to make a timer for the amount of time it takes to get some data back, not necessarily all the data. But what's fun is the way that you inject through Spring, and you might overlay that setting, you may inadvertently actually reset other settings along the way, and we've seen that. So there was one of the product teams was trying to set a socket timeout that they believed was a duration mode. I don't know, let's say 5 seconds. And what they actually did was they reset one of the connection factory classes back to its default, so now they could only concurrently make 2 outbound calls to that endpoint. And so they got their timeout, and that tested well. They shipped the code, performance just completely tanked, right? And it's because, I think there's a lot of, when you're working with Spring, you really got to be careful. And it's seems really convenient, I need to initialize this object, and I'll, instance a new whatever factory for it. And you got to understand every single setting in that thing that you hadn't done something to harm yourself. So it's the same thing for JPA. There's a billion settings, it seems like, for that. Just know the ones that you're going after, and I think it's also, I'm going to keep taking us back to that baseline, because anytime you make some of these tweaks, you really got to understand holistically, did it improve the situation, or did it improve maybe this one call, but you lost 15% across the board as a result of that.
Yeah, I feel like JPA itself, I don't want to say makes people lazy, but they become very dependent upon that it's just going to do its job, so I don't need to do explain plans. I don't need to analyze any indexes or like analyze queries. Like you said, they actually can live side by side. You could use like a JDBC template and like, JPA and just optimize what you need to optimize.
Yeah.
So I think that's like one of my concerns about like when you use some tools like that do too much. Like even Spring Boot, right? It's so opinionated. It's doing 100 things that you don't.
Well, I mean, yeah, in our most critical systems, I mean, we tend to shy away from ORMs, and there's just a little bit of history there. I mean, I've written them in the past for AllState as well, and it's one of those things where you can get them pretty good, but probably not perfect, and at some point, when the scale and throughput just becomes immense, you got to have control over it. So, but great to get started.
No,
absolutely.
Understand when you've outgrown it, I think, and that's probably true for a lot of things. The framework.
Even if you want a POC, you can whatever you use Flyway H2 database and JPA, and you're good for your POC. You're not going to go to production with that.
Joe's
Or you
passionate about JPA.
Yeah, I do. I like
that.
That is like one of my nerves.
Who knew from the data guy?
Yeah, I think we're starting to kind of wind down like what we really wanted to get out of this discussion. But what I'd like to know is kind of like from both of you, like what are some of like the greatest lessons that you've learned as far as optimizations? Like if we're taking what are your greatest takeaways throughout your career so far?
Like something that comes to mind, don't be too early to point fingers at others.
What?
Like it seems natural and easy, but a lot of times, like when you really start analyzing, it's really just application code that we're creating that could be more proficient. There's a lot of times from my takeaway. So it's really, again, having that information understanding is one of the kind of takeaways. From a tuning and performance, it's really being knowledgeable of the tech stack, knowing the 700 and some plus attributes that you can tweak. You will have to get to that level at some point in time. Usually in larger scale applications, something you need a high throughput. You need the experts. You need to be knowledgeable. Reach out, community and others, because you're not going to know all 700 of those things off the top of your head.
Yeah, I would probably say my biggest lesson learned is like never underestimate what really creative people can produce. You think you're smart enough to beat like a native hardware lock, and you're going to come up with it in managed code. Yeah, that's probably not a good idea, and you probably get into some trouble at some point. I mean, I think people hand-rolling their own locks has been one of those. You would not believe, just, again, people leaving sleeps in code, or, God, interactive prompts in server applications. Like, don't do that. Just sit there like a fool when it hits that condition, but it's happened. They're easy to identify. I mean, they're really annoying. But it's also those problems, too, where you're just, it's run well for so long that you just assume that it's good. And I remember when Microsoft says I was big in the Microsoft stack for a long time. They shipped Windows Server 2003, and that's also the same time IS6 came out and CompoZed 1.5 came out. And all of a sudden, everybody's window DNA, you remember that architecture? Some folks?
Yeah.
Everybody's apps started becoming way more available. And they're like, this is great. Microsoft is brilliant. The servers are so good. Like, I knew it was in our code. And then, you know, IS would just reset itself every 27 hours, and the same thing for CompoZed. So it would just proactively know that either their code is trash or your code is trash, and it's just, let's kill it before it gets into a bad state. And it's kind of the same thing here. Whenever you get really, really, really creative, and sometimes you have to, right? We've all jumped out of kind of probably back into native code to solve a specific problem. Make sure you test the heck out of it, and you got the profiles in place, and you got the tools. I think one of the worst things you can do is put off performance testing, like we said, you know, a week before you go prod. Because you almost have to decide up front, do you care about performance? And it's a funny question, because your stakeholders, your business are always going to say, of course we care about performance. Like, great, are you willing to prioritize, you know, ensuring that we've got the right tools and that we're doing performance up front versus some features, and then it becomes a hazier discussion. Or we need to invest, you know, maybe into APM type tools or more sophisticated analysis, so that as this thing continues to grow, you know, we're adjusting accordingly. For us, our the load of the applications and the scale is fairly predictable. We're lucky. There's not that much variability, and you can go, you know, whatever your favorite number of times bigger in, and you're determining like your technical performance test profiles and stuff, and say, okay, we're going to cover like 10x or 100x, you know, normal or countrywide load. But then that kind of changed the game, even from a testing team organization. I think I said that backwards. We have an organization that's kind of dedicated to testing. We're lucky. But as we switch to more PaaS hosting or cloud native workloads, like the way that you think about it, TPT has to change accordingly or as well. So it's not about just running up, you know, a horizontally scalable application until it breaks. It's interesting, but you almost need to understand like what the capacity is within that one container, that one workload, so that you can figure out, you know, if I am just going to scale it out horizontally, is it financially, you know, is it economic to do it? Because I mean, cloud makes it really easy to scale out almost everything. Same thing for like our internal PaaSes, but it's one of those like, well, I've been throwing an instance at it, you know, every other week for the last 2 months. When is it maybe time to open up the patient and see if we can do a little bit better? And you start slow with that stuff, man. You hopefully by the time you're getting to memory dumps, you're doing GC tunes or JVM tunes and other stuff, you've run out of options. Like, you really don't want to go there, especially not immediately. And I think that's, you know, like what stands out for me is when you get really, really super creative and you think you can beat the frameworks that are shipping, or you think you can do a better lock than a hardware lock. I mean, it's like rolling your own encryption, right? Like you can. I really, really would recommend that you do.
Okay, very good. I think some of the things that I wrote down, that I think some of the takeaways, and I think we just, you know, we've kind of all experienced this as, like, maybe there was a critical lab, like, where we've pulled other people and we've mobbed on it, like the importance of like, even like really, really knowing the framework, like spraying really, really well.
Oh yeah. Yeah, whether you like it or not, you will debug at some point in spring, or like we were deep into Catalina one time. And I remember probably about 5 years ago, same in the Microsoft stack, the vendors were doing a lot more heuristics and built-in analysis, like right into the tools. And like, we promise, we got it this time. You're never going to have to read a memory dump ever again. The tools are just that good. And I won't call out the one vendor, but we were reading their memory dump literally 2 weeks later after we put that in place. So, you know, at some point, and it's almost like a good problem to have. It means the app is, you know, really critical. It's under immense load. There's fun problems to solve. And hopefully you don't go from like 0 requests a second to 50,000 requests a second. you've got some ramp up along the way where you can kind of grow, learn. Always got to keep learning in the space to keep up to date.
Absolutely. Okay, I think that's sort of the conclusion. Like, we can open up if you had any
That's the fun
questions.
part, right?
Yeah.
The Q&A.
Yeah, I mean, just don't ask us
Thanks
what
for bearing with us.
the GC questions are, or
I'll give you the
switches.
settings. Again, at your own risk.
Sorry, I gotta take off.
Oh, thanks for coming, Justin.
So I haven't had a chance to talk to everyone. My name is Ritesh Singh. Hi. So I heard a lot about like common architecture patterns, microservices, Java, Spring Boot, things like that. I'm curious because I know the real world does not work completely in isolation. How often you have to deal with things that are not that, either services that are still on-prem, microservices or monoliths that might not be written in Java, external dependencies, like other SaaS platforms that you might have to integrate with. What are some of the lessons you've learned in kind of dealing with a mixed bag in your architecture?
I mean, I know some of the problems that we have, but I don't know how much we can elaborate on.
Well, I mean, that's a great question. I mean, that's where, if you can get into some of the APM tools, that can cross the technology stack boundaries and stitch stuff together, that's really beneficial. But of course, everyone has legacy systems that probably don't have that in place and probably don't have minimums. Like, when you kind of got to shift towards, like, assume that your friends are going to betray you within the company, and that at least you have to be able to help identify that, look, I can prove that it's just not on my side. So this is what Dewey brought out about saying, point a finger. At some point, you may have to go back to that at a product team and, like, say, look, man, we've got a duration instrument around your call. It says you are 2.95 of the 3 seconds that this thing takes. You're going to have to look into it. And then depending on the level of sophistication that they have, or, I'm sure everyone's hit the problem of it's an old app, it's a legacy app, it's in run the business mode. No one really knows that app anymore. But it does its job well, just kind of leave it alone. Maybe we ignore it, maybe we give it a pass. And that's where things like even, we picked on Hystrix a little bit as kind of being a crutch, but that's a good way to create some isolation and, maybe kind of quarantine off some of those troublemakers. But I think the first step, again, is just being able to identify it and say, yeah, it disappears into your black box. That I don't know what's going on there, but I know it takes a really long time to come back if it comes back at all, and maybe you start that way. But what do you guys?
I'm not sure I can say something. Just thinking. Across different centers and stuff. I mean,
You're
there's
still picking on databases?
Well, yeah. Well, I'm just thinking we have some of that latency, so.
Sure, right. Everybody's got queries that probably ran fine when you had 100,000 records in the database. Now you got 10 million records in the database. Now that same query is kind of junk. So it's the same thing. Understand that this query is consistently running hot above SLAs, and you're able to go back and either get your DBAs involved, or again going back to that product team. But it's an interesting challenge, and it really speaks to that. You can control the parts that you can control. And so you really, if you're not going to go with some sort of an APM tool, you got to make sure that you're measuring every single outbound call. Because at the end of the day, your customers are probably going to hold you accountable if you're kind of the face or the front end of this thing or whatever. Even if you're compositing, a half dozen services in for this one kind of function, they don't care, right? They know I clicked this button, I sat there and waited, it didn't come back, or it did, and it didn't do what I needed it to do. Fix the problem. But
is there any stories of optimizations shifting architectures? Because sometimes one architecture will be the bottleneck because you cannot optimize because of you're doing RPC calls, or maybe you need to decouple things in an event-driven manner. Is there any stories like that where the actual architecture was the culprit of the performance?
I mean, I think maybe even an extreme case is like at one point we had to change the tack. You know, it's not an anti-Java thing. It just wasn't a good fit. Like the amount of performance that we needed to get out of this one widget. I mean, we had to shift it back into like Golang, which again is an extreme case. You know, but we pulled out all the stops. We tried everything that we can do. And again, when you're managing for maybe a cloud-hosted environment too, you know, memory usage, CPU time, all that stuff, you're paying real money for that. So it goes back to maybe the other recommendation. I know we're trying to stay away from maybe polyglot type architectures and technologies, but like sometimes, I mean, if that's the cure, I wouldn't rule it out. Now again, maybe you don't want to start there, but yeah, architecture shifts sometimes, like
Best
you
tool
really,
for the job.
you can't get around it, right? You've squeezed everything out of it you can, it's not really worth the investment, you gotta change it up. Hopefully it doesn't have to come to a rewrite, but I mean, even just shifting the mindset from, I mean, how many async REST template calls do you have in your code? Probably not enough. There's even better ways to do that now, you know, if you're getting into some of the reactive programming. But at the other hand, if you start out really, really complicated and you have a workforce that maybe really doesn't understand some of the emerging patterns and technologies, then at the end of the day, maybe that's not good to immediately jump there either, until you build up those skills.
Got a question. So I was just wondering, the tooling that you use for performance and optimization will you say that is more created in-house, or do you actually pay licenses for some of the products?
Both.
Both?
Yeah.
Like 50-50? Or?
Depends on the team, right?
Yeah. I mean, our biggest systems, we have commercial products in front of. The mid to small systems, we've got some homegrown stuff. And again, like not everything needs full, you know, just down to almost the method level type instrumentation. But yeah, it's a mix.
Okay.
There's a huge cost associated with off the project, so you gotta justify it. Some teams can. Any other questions?
So do you have, on the monitoring topic, enough uniformity of the deployment stack that, you know, a good set of tools helps with whether it's the customer and agency facing system, the, you know, the analytics stuff, I'm sure, as an insurance company, you've got actuary stuff out the wazoo as well.
Yeah.
So do you, I mean, in general, has AllState gotten to a point with its technology transformations where there's enough commonality that good sets of tools really help with the observability capabilities?
Yeah, I mean, inevitably at scale, right, you start to converge some of this down. Like we'd all like infinite choice, you know, in some of these solutions, but, you know, at the end of the day, you kind of got a business to run. So I would answer that is it's getting much better. About 5 years ago, we started down the CompoZed journey, which was as much about driving a very product-centric mindset into the organization and kind of lean enterprise practices, as it was a modernization of our tech stacks. And we really started going heavy into like a PaaS deployment model, which has helped immensely on, you know, kind of the standardization of some of that stuff. And it improves everything across the board, like monitoring, observability. We used to joke around, like before, if you had 1,000 apps, like we essentially had 1,000 PaaSes, you know, because everything was just a little bit different, everything was kind of bespoke. And so it made it very difficult. But I would say strategically, you know, you have to kind of converge some of these things down in order to achieve that at scale. Or, yeah, you're going to get into the situation we talked about where you got one app that's, you know, very, very observable, you know what's going on, and then it heads off into like the mesh of old stuff, and it's like, I don't know, it's all good up until this point, and then it gets in there, and then who knows. So.
Yeah.
And is the CompoZed part of an incubation group that's trying to help, you know, provide best practices up front? You know, is there other places that will have, you know, kind of reactive SWAT teams that are, you know, experts in tuning almost anything and everything, where they end up
Yeah.
creating specialized SWAT teams to run around and try to address the problems and provide feedback to the teams that created the problem in the first place, who don't have the expertise.
I mean, I was in that role, Dewey's in that role probably for like almost 10 years, in that very like SWAT team, reactive, like it's a horrible, I mean, it's a lot of fun, and I always thought that you know, it's always interesting challenges, like seriously, like debugging blue screens of death were one of my favorite things to do for a period of time, and it's almost always a bad driver that you have, so that's the tip. If you're still experiencing those, go update your drivers. You'll probably be okay. But
Because ideally the knowledge is getting further upstream in the life cycle so that bad practices or potential issues are caught up front, but that's hard to really scale.
So I would say, you know, we're trying to move, like a lot of the high-tech companies have been able to, you know, you codify a lot of what used to be kind of paper process or human monitored things, you know, even in architectures, right? You try and push that into the codified front as much as you can. From a CompoZed Labs perspective, there is actually an enablement or customer success organization within there that as new product teams are coming on board, and they're not only getting exposed to maybe new agile methodologies, but obviously tons of new tools in the tech stack, that they're there to help them to ensure they, you know, they're getting off on the right foot, you know, not just getting, I spent a couple of months really, a couple of years ago with all of our product teams in our labs in North America, just pairing with developers and experiencing it as they're going through it. And I saw a product team that was built up of mostly new hires, pretty much out of school or 2-3 years experience, where they spent 3 weeks messing around with some Jenkins stuff. It seems like, you know, that's probably something that we could maybe automate away, or, you know, it might fall into that commodity bucket that probably shouldn't be spending all that time in there. And then that's kind of like what our focus of our organization is right now. You know, how do you really help product teams, you know, realize their code in production as fast as they can code it, and still, you know, check all the boxes from like an audit and compliance and all those things that we still have to do. But we used to rely on manual processes and people to do it. Now get those into the systems, get them into the platforms, and then really unlock the potential of the product teams, because now they're spending those 3 weeks or whatever it is on features, or, you know, making their customers happy, instead of things like a system can just go figure it out.
Yeah, I wanted to like go back to one of the other things that you had mentioned was the monitoring. Now, I don't have Dave's like historical perspective of like where we came from, just kind of like know where we've been at the last couple of years as far as like monitoring. And I think AllState's actually doing pretty good. So if you're a new application team and you want monitoring, there's definitely a very formal process where you can get so our command center to monitor your app. And I think it's great. Like, we have a lot of similar processes like that without like not knowing what I can say and what I can't say. But I think AllState itself is like those processes exist, that if you want it, it's there, and it's fairly automated to do it.
Well, like,
Yeah.
just in general, I love this company. You know, part of the mission is like we help protect you from life's uncertainties. Because, well, what does that mean? Well, we're like a big data company at the end of the day, right? We're selling you insurance products, which are kind of like contracts or promises, but then it's just all based on our systems. So yeah, we make a lot of investments in, you know, everything from operations to, you know, cybersecurity and all that, just across the board. And then we have the privilege of trying to figure out how to make that just seamless and frictionless and build it into, whether it's the pipelines or frameworks or other things. So again, if you're that brand new product team, maybe with limited experience, right, the quality of application that you're putting out is, you know, just going to be industry enterprise class right out of the gate. And do so in a way, this is different from before, like where we had steep learning curves on proprietary frameworks and other things. You know, do it in a way that feels natural. Like if you're a Spring developer, I don't want you to have to feel or even see some of the things that we're doing, you know, in Spring behind the scenes on your behalf. I want to be able to tap into the 4+ million, you know, Spring developers globally and make them successful and feel comfortable, you know, in their contributions. And I don't want them to have to spend 6 months learning stuff when they've already made the investments to learn Java and Spring and a bunch of other stuff.
Any other questions?
Okay, I think we're gonna move to the raffle. Well, thanks a lot.
Yeah.
I think it was great.
Thank you guys. So